Hey, this is Miss Park, another video in the series of transformations. So we've learned about translations, reflections, stretches, and some are vertical and some are horizontal. And so today we're going to put them all together into an equation that looks like this. Okay, so this looks like a big mess. But if you imagine that it was something like y equals 3 square root of 2 times x minus 5 plus 7, then knowing what each of these parts does will tell us what all the transformations are together. Okay, so let's review. When we have, let's look at all each of these letters A, K, P, and Q and see what their significance is. So whenever we have a number at the end, right, regardless of what the other transformations were inside, we just have a number outside of the f of x on the end. That is a vertical translation, q units up. Okay, now if q is a negative number, then it would go down, right? What is another vertical transformation that's here? Q is vertical. Which of these other letters, A, K, or P, are vertical? So the way to know is anything vertical is going to be outside of this f of x. Remember, everything that's inside of f is input, and then f of that is going to be output. So this thing that's outside the output is going to be affecting the y's, which is the vertical. So this A was a vertical stretch by a factor of A. The other thing the A tells us is knowing whether the A is positive or negative. A also tells us if there is a vertical reflection. Okay, so once again, you know all these things are vertical is because they are outside the f of x. If you look at this radical function, the 3 and the 7 are outside the radical sign. I'm just going to take off this little bit of radical sign, just a little too long. There we go. Okay, so now let's look at what's on the inside. What is the K and the P? Okay, so now this x minus 5, pretend all this other stuff wasn't there. That x minus 5, this P, is a translation, so that's a movement or a shift, P units right. And if P was a negative number, you'd see a plus in here. So like, let's say in here, P is negative 5, that looks like a plus in here. That would be movement to the left. Okay, and then the last thing is our K. So I'll remind you, if you had 2x in here, even if it didn't have the 5, but 2 something inside the f of x, that is a horizontal stretch by a factor of not k. Remember, this one was the one that's factor of 1 over k. So that was a little special. And the other thing that k tells us is whether there is a horizontal reflection. So let's say, for example, instead of 2, I had negative 2. Then that would be a horizontal reflection as well as a horizontal stretch by a factor of 1/2. Okay, so I'm going to do a couple of these with you. So let's look at this example. It's just the 3 points. We don't have an equation for it, but that's okay. The first thing we do when we are combining transformations is to write the transformations in words. I'll let you notice, though, that the way they've got this equation written here and the way they've got this equation written here are different. See if you can tell what's different. See, there's an A value, so that's the same. There's a Q value, that's the same. Now inside the f of x, there's a k right there. And then you have x minus p. What's different? I'll give you a clue. It's on the inside. What's different? Okay, so you may notice that in this equation here, the x minus p are in a bracket, which means that the k has been factored out. Look here, there is no inner bracket, so we're going to have to factor out this k to see what's left inside, to see what goes in the bracket. Because if I want to read the translation, the horizontal translation, I can't read it like this. I'm going to need to factor out the k until I have brackets, and then I can read it. So let's first take a step here to factor out that k and see what we're working with. So I'll use square brackets because I'm going to have a bracket in a bracket. I will factor out the half. That gives me x minus 2 divided by the half is 4. And now that I've factored out the k, I can see that the a is 2, sorry, the a is negative 2, the k is 1/2, the p is 4, and the q is 5. Okay, so only after I factor out the k can I actually see what they all are. So first things first, we're going to write out what that means. So a is negative 2, that means that there is a vertical stretch by a factor of 2. And a is negative, which means there's also a vertical reflection. So that's just from a. Now k is 1/2, so that is a horizontal stretch by a factor, not of a half, but of 2, right? 1 over k. The p is 4, so that is translation, so movement in other words, 4 units right. And q is 5, which is a translation, 5 units up. And those are all my transformations. And now that I've written them in words, the mapping rule should flow directly from these words. So let's see what happens to the x's and what happens to the y's. So the x's, which of these variables is going to affect the x's? Which of them are horizontal? So this is the k and the p. So I'm going to put a little horizontal here, h and an h, and a little vertical for the a and the q, so that you know which ones go with x and which ones go with y. So I'm going to have a horizontal stretch by a factor of 2. So I'm going to multiply the x's by 2, and then I'm going to add 4 units. So that's going to be my new x's. For the y's, I'm going to have a vertical stretch by a factor of 2, but I also have a vertical reflection. So I need to multiply by the negative 1, and then I have 5 units up. Right, and so now I have a mapping rule for the for all transformations together. So if I take any point that's here, so negative 4, 2, I can find out what the new point is by substituting this x and y into here. So that would be 2 times negative 4, which is negative 8, plus 4. So that's negative 4. And negative 2 times 2 is negative 4, plus 5 is 1. So the point negative 4, 2 becomes negative 4, 1. Comes over here. Let's see what the next point is. 0, negative 1. So 2 times 0 is 0, plus 4 is 4. And then negative 2 times negative 1 is 2, plus 5 is 7. So now I have 4, 7. 1, 2, 3, 4, 5, 6, 7 over here. And I can connect those dots. Okay. Oh, oops, wrong one. Let's do it again. It's the new dot. So 4 and 7, these two. Okay, and then I'm going to have my last point, which is 3, 1. So that's going to be 2 times 3, which is 6, plus 4 is 10. And negative 2 times 1 is negative 2, plus 5 is 3. So I have the point 310. Well, that's going to go off my grid. So I'm just going to say that this is 10. I'll say that this is 10 over here. And go up 3. 10, 3. 1, 2, 3. Right there, right on my writing. So I'm going to connect those two. And that's my new graph. And I'm going to label it. I won't do it here because there's all this, my other writing is here, but I'm going to label it y equals negative 2f of 1/2 x minus 2 plus 5. Okay, and that's how you transform with all the transformations all at once. You can do this down here, try it yourself. Remember, you must factor out the k. If you don't factor out the k, then you'll think that the p is negative 1, but it's not, because to figure out your p, you must have k outside the bracket. So you must have k factored out. So you'll end up with the wrong p. Let's see what's on the next page. So there's an example with quadratic. There's an example with radical. So I'll just remind you all the time, okay? So you're going to list the transformations in words all the time. You're going to always, I'll put above it, you know what? I'll put a different color over here because it's easy to forget. Factor out the k. Okay, so you'll factor out the k, then you'll list the transformations in words, then you'll write the mapping rule, and you'll transform the points of the parent. So now in this case, the parent is not given to you, but you know the points of the parent because you know for radical it's 0, 0, 1, 1, 4, 2, 3, and 9, 3. Okay, so you'll transform all those points, you'll plot the points. And then, very important, is label the graph with the equation. And that's how we graph. Okay, and do one more. Just look at the last one. So the last one is going to be reciprocal. All right, we have to look at the equation very carefully, decide what is A, what is K, what is P, and what is Q. All right, now Q is the easiest. It's the one that's hanging off the edge there by itself, -4, so we know what that means. A is easy too because it's outside this f of x. This f of x is this fraction. That negative sign could sit outside the fraction. It could also sit with the numerator. In both cases, that's your A. Okay, now underneath here, we don't usually write 3 plus x. We usually write x plus 3, and that's equal, right? It's the same thing. So now we can see there's no k value to factor out. So we can just get our p is -3. There's no k value, so that means k is 1. So I'll just write the transformations with you again. A doesn't have a stretch, right? Doesn't show us a stretch because the size of A is 1, but there is this negative, which means that there is a vertical reflection. Okay, this k is 1, so like there is nothing there to write. There's no transformation there. P is -3, which means it's translation 3 units left. Q is -4, which means it's translation 4 units down. So we're going to write the mapping rule. Okay, so what's happening to the x's? Remember, k and p are the horizontal things. So x is not multiplied by anything, but it does, we do subtract 3 from it because we're moving to the left. So then we're going to go x minus 3. And then the y's, not multiplied by anything, but they do get multiplied by -1 because there's a reflection. And then they go down 4. And that's our mapping rule. Now I'll remind you, this is the reciprocal function. So we don't need that whole original table with all of the fractions. We just need our two anchor points. So 1, 1 and -1, -1. So 1, 1 becomes -2. So I'm going to sub in 1 there and sub in 1 there. -2, -5. -1, -1. So -1 minus 3 is -4. Negative times -1 is 1. Minus 4 is -3. So that's where my 2 points are going to go. Now I'm going to put the 2 points, -2, -5, and they're just going to sit there. I'm not going to know exactly what to do with them. -4, -3. They're here, right? What do I do with them? Well, now it depends what happened to my asymptote, right? Where did my asymptotes go? So with reflections and with stretches, the asymptotes don't change. When do the asymptotes change? Only when we're moving from side to side. They're just vertical lines or horizontal lines. So stretching them doesn't change them in any way. They're still the same line because they go on forever. So the only way they change is if you move side to side or move up and down. So that's going to come from the translations. So since the entire graph is moving to the left, then my asymptote that used to be x equals 0 is going to move to the left. So it's going to become x equals -3. So let me write them here. X equals -3. Now my other asymptote, which was y equals 0, the entire graph is moving down 4 units. So that's going to bring the asymptote also down to y equals -4. And now that I've got my asymptotes, then these 2 points are going to make sense. So let me put one, y equals -4 is through here, and you can see that that makes sense for these 2 points, that it goes between them. Notice I'm labeling everything, including the asymptotes. Then I have x equals -3. Okay, and now you can see these points make sense because they're on sort of diagonal quadrants, right, with the asymptotes. So now I'm going to hug my asymptotes. And I'm done. Okay, so we just have to find a nice corner to put our label. -1/3 plus x minus 4. Okay, and that's it. That's everything. So we'll have to add to our list of steps back here. What are your list of steps? Label the graph with the equation. And also, if reciprocal, label the asymptotes too. Okay, and that's it. That is your combination of transformations. Thank you for watching.